now that we know a formula to compute this mu of x, let's go ahead and apply it to the previous example I had, right? Which should be x squared at the end of the day, what we get out. So right, we had this example here, so it was 3y plus y squared over x plus x plus y times y prime equals 0. So our Mars of x comma y, our Neptune of x comma y. And I tested before that, partial Mars partial y was equal to 3 plus 2y over x, and that did not equal partial Neptune partial x, which equaled 1. So let's try out this attempt, this method that might or might not work, and see what happens. All right, so this is going to take a little bit of algebra, so let's go ahead and get started. So this is going to equal, so partial Mars partial y is 3 plus 2y over x, and then partial Neptune partial x is a minus 1, and that's all over just Neptune of x comma y, which is x plus y. All right, well, let's try and get this fraction simplified a little bit. So let's see, if I make a common denominator, I can have 3x over x. So the whole thing's going to be over x here. Then I have 2y over x. Then I have minus x over x. Then that's all over this x plus y. Well, I can simplify that fraction. I can make that into 3x plus, I'll do it in steps, plus 2y minus x over x times x plus y. And then from there, I'll have to continue. So let's see, 3x plus 2y minus x, that's 2x plus 2y. And that's all over x times x plus y. And that can be simplified a little more, so I can take the 2 out. So that's x plus y. On the bottom, I have x times x plus y, which simplifies to 2 over x. So this is really good news because this mu that we had made assumptions and tried to simplify that partial differential equation so that we just have mu in terms of x. In order for that to work, for that assumption to actually result in something usable, we had to have the simplification down to just a function of x, which is true. That's what we have. So now we have mu prime of x over mu of x equals, and I've left a little, I'll write it, 2 over x. So now let's go ahead and integrate. So now I have indefinite integral of mu prime over mu dx is going to equal the indefinite integral of 2 over x dx. All right, so the integral of this, mu prime over mu, is natural log absolute value of mu of x. The integral of 2 over x is 2 natural log absolute value of x. So I want to get rid of these natural logs. Let's exponentiate everything. So then we end up with e to the natural log absolute value of mu of x. So equal to e2 to the natural log absolute value of x, which is the same as e natural log absolute value of x squared. So now I can drop the e and the natural log here cancel, the e and the natural log here cancel. So I have absolute value mu of x is equal to absolute value of x squared. And then I'm just going to drop the absolute values. They're always going to be positive there. So mu of x equals x squared.